So if I'm given arm theta, this is how I would convert it to x and y. If I'm given x and y, here's how I would find arm theta. We have to be extra careful with this one to make sure that we're in the proper quadrant. When you do inverse tangent with your calculator, that only gives you specific values in quadrants 1 and 4. So here we go. Oh, and so we end up with, I'm going to draw this r comma theta is the way we write the order pair for polar coordinates. Unlike rectangular coordinates, which has exactly one way to write it, you go so far in the x direction, you go so far in the y direction. Polar coordinates, there's actually 4 different ways to represent the same thing. So I'm going to stand here and I'm going to try to get this Zach again. One way is I can go in the positive theta position direction, and go positive radius to get to where he is. Another way is I can go the negative theta, and then go in the positive r direction. Another way is I can actually go to here, which is positive theta, and go in the negative r direction. See where I'm going with this? There's 4 different ways of doing this, right? The other way is I can go in the negative theta direction and the negative r direction to get to where he is. Does that make sense? Before I continue on with this, I'm trying not to cough, because I'm not sick. So let me just sort of dabble into Calc 3 just for a second. So when we're dealing in 3 dimensions, and you don't have to write any of this down, I just want to introduce this. If we want to talk about a point in rectangular coordinates, we would do this. We would have a point in 3 dimensions. This would be rectangular coordinates, x, comma, y, comma, z in this case. So far on the x, so far on the y, up to z. There are 2 other ways to represent this. I'd like to point out that the blue dot is the same as the blue dot here. So I would do this, x, y, z, for the 3-dimensional point. All in octant 1, right? So if I wanted to apply this to the 3 dimensions, there's r and there's theta, all in the xy plane. So this would be represented here. And here. So you would go theta out to r and then straight up. So in 3 dimensions, we're going to say that the projector is my goal now. Okay? Right, and in fact, I'll be here. So I'm at the origin. So rectangular coordinates, I would go like this. Of course, I can't walk through that, so I walk through it. I walk to here, and then I go up. That would be rectangular coordinates. In polar coordinates, we don't call it that in 3D, we call it something else. That's okay. I would do this. I would be here. I would turn like this. I would walk straight to underneath it. And then I would go to the z. So the z is the same for both. Now I'm going to really screw with your head. There's a 3rd way that we can get to the projector from the origin. Okay, we have rectangular coordinates, we have polar coordinates, now we're going to have spherical coordinates. We're going to learn about that sphere. So we're going to do this. I'm at the origin. I am turning theta, the same theta. From the z-axis, I'm going to go an angle. And then from the origin, I'm going to go straight there. 3 different ways of doing the same thing. Let me do again. Okay? Theta is the same. I'm turning to here. Then the theta is the angle from the z down. Drop dead here. So my angle here is called phi. And then from the origin, I go straight there. So there's 3 different ways in in 3 dimensions. Pretty crazy, huh? So your talk through teacher, whatever that ends up being, will go through that. Probably won't do what I was doing. You get the idea. Any questions? So let's stick with, and by the way, the whole reason why we would need something like this is when we start integrating, if we can convert it to other forms in our 3-dimensional piece that make it more simple. So for example, spherical coordinates are easier when we're dealing with the sphere. So everything with drops down becomes very, very easy to manipulate. Okay? The polar coordinates in 3D is called cylindrical coordinates. Anytime you're dealing with a cylinder, using cylindrical coordinates makes everything drop down and be like 20 times easier. Make sense? So that's kind of the direction that all this is going to be going when you hit 3D. Back to 2D. Here we go. Alright, so let's do some converting.
Safe in 2D.
Okay. So we are given x and y, and we want to go into polar coordinates. So in this case, what I'm going to do is I'm going to, again, note this is x, this is y, and I'm going to go to these formulas here. Let's figure out what r is. We okay? Now we need to figure out what theta is. Oh, dang it, I meant to make, shoot, that's okay. We'll just get a messy answer in this case. In fact, let's do things in degrees. Go ahead and convert your calculator to degrees.
Brought my cup.
Could you please figure out what theta is in degrees?